Hello everybody, so today we will be going into chapter 7. So chapter 7 is on geometrical optics. So I think there are 3 subtopics in this chapter if I'm not mistaken lah. Oh yes, so there's 3 subtopics in this chapter. So the first subtopic is on reflection at a spherical surface. Okay, so in this subtopic you should be able to state what is the radius of curvature, which is r equal to 2f, where f is the focal length. Okay, so it is only applied for spherical mirror lah. Okay, and then you have to also be able to sketch the ray diagrams with a minimum of 2 rays to determine the characteristics of the image form. Okay, and then you also have to be able to use this mirror equation. So focal length will be positive for concave mirror, whereas negative for convex mirror. Okay, and then you have to also be able to define and use magnification for the equation, which is this one lah. Okay, the capital R can also be written as small r lah. Okay, this one is small r pun boleh. Okay, so now reflection of light. So we know that reflection of light is actually the return of all ataupun a part of a beam of light when it encounters the boundary between two medias. Okay, for example, look at this figure 1. A reflection of light can be seen from the smooth shiny surface lah. So when it hit the surface here, it will be reflected back to this side here. Okay, so this eye can see the light lah. Okay, and then all these rays are parallel to each other lah, ataupun they are moving in the same direction, sebab this is for a smooth surface. Okay, however for a smooth surface we call this a specular reflection ataupun regular reflection. Okay, so what happen if the surface is not smooth? The reflection is known as diffuse reflection lah. Okay, so as you can see here, the reflection after it being reflected on the surface, it moves at different direction. Okay, so remember, for regular reflection it should be parallel to each other. Okay, the reflected rays should be parallel to each other, but for diffuse reflection the reflected rays is not in the same direction lah. Okay, right, so for both types of this reflection, diffuse and regular reflection, they both obey the law of reflection. Okay, so what is the law of reflection? It states that the incident ray, the reflected ray, and the normal all lies in the same plane, and then the angle of incidence I, so the angle of incidence should be equal to the angle of reflection R. Okay, so basically the law of reflection state that it needs to lie on the normal, it should lie in the same plane lah. Okay, so this is the incident ray, this is the reflected ray, and this is the normal, so they will lie on the same plane. Okay, and then the next one, it states that the angle of incidence is equal to the angle of reflection lah. Okay, okay, now spherical mirror is defined as a reflecting surface that is part of a sphere lah. Okay, so there's 2 types of mirror, which is the first one is convex and the second one is concave mirror. Okay, actually I should have labeled this one correctly, because now you would expect that this is convex mirror, this is concave mirror. Okay, so this part here where you need to focus is up till this part lah. You don't actually have to draw the whole circle, you just need to know that this is a concave mirror. Okay, so concave mirror is, it will be curving inwards. Okay, so this is concave mirror. So let me just draw it again with a bigger size. Okay, so this is concave mirror, and then convex mirror, it is curving outwards lah. Okay, right, so I'll correct this later before I upload the notes. So now the terms of this spherical mirror is very important, because you actually need to know where is it in the diagram lah. Okay, so point C here is telling us about the center of curvature, which is at the center of the sphere lah. Okay, And then r here, capital R, or it can also be written as small letter r, it is defined as the radius of the curvature, which is basically telling us the radius of the sphere lah. Okay, and then the point P here is the point at the center of this mirror. Okay, and then this blue line here is the principal axis. Okay, so the principal axis is all behind the mirror. Okay, so this one is in front, this one is behind lah. Okay, and then AB here is known as the aperture of the mirror. If you remember, for a camera, as you are zooming in or out, the black lens here, the black thing, is actually decreasing or increasing in size kan as you are zooming in or out of the camera. So that is actually the aperture lah. Alright, okay, now focal point and focal length. So let's consider this ray diagram. This is a concave mirror and this is a convex mirror. So remember, the capital F represents the focal point and the small letter f is the focal length. Okay, so let's look for concave mirror. This is the concave mirror. The focal point is defined as the point where the incident parallel rays, okay, converge after being reflected on the mirror, meaning that the reflected rays converge at a point. Okay, so it converge at a point. The point is known as the focal point. Okay, so it is shown here lah, right? And then for convex mirror, it is defined as a point where the reflected rays diverge from a point behind the mirror. Okay, so the reflected rays diverge from behind, diverge at the point from behind. Okay, so this one is the depan lah, and then for the convex mirror, it forms behind the mirror. Okay, so because it forms behind the mirror, this focal point is known as virtual. Okay, virtual because it is at the back of the mirror. And then for the concave mirror, its focal point is real because it lies on the principal, and also, sorry, not because it lies on the principal, because it forms in front of the mirror. Okay, all right, now the focal length, the small letter f, it is the distance between the focal point and the pole of the spherical mirror lah. Okay, so it is not the radius of curvature, it is a point between P and capital F. Okay, so the paraxial rays is defined as the rays that are near to and almost parallel to the principal axis lah. Kalau ada satu ray yang almost parallel to this principal axis, it is known as paraxial rays. Okay, all right, is it okay? This is a very long subtopic. Okay, now let's look at the relationship between focal length and radius of curvature. Okay, so basically you don't have to know how to derive this equation, but if you do want to know how to get this equation, just look at this one here lah. Okay, so I'm just gonna go through this equation directly, because just so that you don't get confused and just so that our video is not too long. Okay, so this is the equation. Radius of curvature is equal to twice the focal length. Okay, so you need to know how to use this equation here. Okay,